Okay, so we're given a surface integral. Now this is a surface integral written in this coordinate notation. I call this a coordinate surface integral. And we want to reinterpret this as a flux of some vector field through that surface. So this is a notation question, really. And the point is that, and so one of the equations we have from earlier in the section is that, well, in fact, let me just go back to where it is. It's right here. Here you go. So flux, right, these surface integral calculations, you can interpret the ds as this. Yeah, and so if you have an integral of this sort, really what that is that's just telling you what the thing is that you're going to match up with that differential inside of this sort of coordinate notation for the vector surface differential. So okay, so that being said, what do we do with this? This is number 5, right?
Yeah.
Okay. So all right, so we've got integral f dy dz. Well, I would write that as, well, there's something dot ds. And what else? Oh, I'm sorry, I forgot to turn back the camera. I always forget that. Here we go. So this is what we're given. And that's flux of, well, we're going to put a vector field here, and this needs to be ds. ds is dy dz, dz dx, dx dy. So what components do I put in here? This is our ds vector, by the way. What components do I put into this vector field f to make this equal to that? Well, okay, f has to get multiplied by dy dz, and there's no dz dx term, and over here there's no dx dy term. So this is one way to interpret that. So said differently, this integral can be interpreted as the flux, surface integral f dot ds of this vector field. I'm sorry?
So that's the answer?
That's the answer. Yeah, so the vector field f is the vector field f of x comma y comma z 0, 0.
But that doesn't mean y and z are 0.
No, it just means that, so keep in mind, x, y, and z are input variables that describe the position where you are, and these are just formulas that tell you how to calculate the components of the field, right? So this field is everywhere. It's just that it's always pointing only in the x direction. Yeah. Does that make sense?
Yeah. Does the f of x and y and z represent the components for just the first component?
Yep, that's right. So that's the conclusion of this calculation. In order to make this look like this, I had to make the field have that function f only in the the first component of the field f. That's right. So think of this as a just sort of a it's, kind of a mix and match kind of deal. It's really all just notation. Yeah. Right. Did you have a question? After this one. Okay. All right. Anybody else on this one? Okay. Yeah, sure.